In this short video, I want to show you a few mathematical properties of Fourier series. These are things it is good if you heard about them. This is not stuff which we will test in the final exam and so on. There are some really mathematically interesting proofs, so if you like a math whiz and want to know details, check it out. Otherwise, let me just tell you 3 or 4 items here, which are kind of interesting. So for example, the first one, theorem 2.4, says that the Fourier series is unique, meaning if you do the Fourier series and your neighbor does the Fourier series, and if you do the right calculations, you get the same results. Interesting here is the linearity. So linearity of Fourier series. So let's say we have 2 functions f and g, and we can compute the Fourier series for each of them. Okay. So this is actually indicated down here. So f has a Fourier series and g has a Fourier series. But we can also look at the sum, c1f plus c2g, and then we can do the Fourier series for the sum. And it turns out that you can actually add the coefficients in an appropriate way. So the first coefficient of the sum would then be little c1 times the first coefficient of f plus little c2 times the first coefficient of g. Okay? And so on. So then you can add these coefficients with the constant c1, c2, and you can add these with constant c1 and c2. So that means linearity. So you can build Fourier series of sums of functions just the same way as you would expect. Here's an interesting one which is called Bessel's inequality. Again, we look at a general Fourier series, and then you can estimate the sum of the coefficient square by the integral of the function f squared. It's an interesting property. As I say, we will never use it in our class, but now we have seen it. Haha. Here we have a uniform convergence result. Alright. So if f is piecewise smooth and continuous at the boundary, so f of L is f of minus L, then the Fourier series converges absolutely and uniformly. So this means this is a case where we have absolutely no jumps. You remember at jumps we converge to the half, to the middle position in the jump. If we have no jumps though, then we have uniform convergence. All mathematicians are happy. Yoo-hoo.